In this section, we're going to add what are called expressions to the code we have available. And that's kind of the last piece we needed to start writing kind of realistic image manipulation code. And in particular, by the end of this section, we'll play with puzzles that are based on images. So that'll be kind of fun. So we've written code like this a lot of times. So here it says print 42. We just have a number, 40 or 100 or 250 or whatever, and it's just in the code. It turns out you can instead write that this way. So it says print 11 plus 31. And the 11 plus 31 here, that's called an expression. And basically, instead of a fixed number that's known ahead of time, we can put a little arithmetic expression. So in this case, 11 plus 31, it's a little problem. The way this works is that when the computer when it gets to this line, the first thing it's going to do is it is said to evaluate the expression. So it just picks out the expression and says, all right, well, I need to work out what number this is. In this case, it just does the addition. So 11 plus 31 is 42. So once the expression's been evaluated down to a number of 42, then the code can continue and just use that number. So in effect, this will just print 42. And so anywhere in the code where we would have had a number like 0 or 255 or 100 or something, instead we're going to be able to put little arithmetic expressions to sort of embed a little computation to compute what number we want to use. And that's going to enable us to solve better problems. So we haven't talked about it up to now, but the pixel has these three extra functions. There's pixel.getRead, and what getRead does is it's kind of the reverse of setRead. It retrieves the number out of the pixel. So there is some red value, 0 or 100 or something. This retrieves it out. And there's also getGreen and getBlue. And so these are going to be very natural to use in expressions to mess with the RGB values in a pixel. So suppose what I want to do is double the red value of a pixel. So if it's 50, I want to make it 100. If it's 100, I want to make it 200 or whatever. So here's some code that does that. And so I'm going to walk through this. And this is this idea of making a relative change to a pixel, whatever it was, change it to triple it or something like that. That's going to be a much more realistic way to deal with the RGB values in pixels. All right, so let's walk through what this code does. So this code is correct. It does double the red value of a pixel. So what the first line does is it calls pixel.getRead, so that's going to retrieve the number out. And let's just say in this case that the red value is 50. So pixel.getRead is going to retrieve the 50. And then here we're using the equal sign in the way we have before to just store that number in a variable I'm just going to call old for the old value. So basically this just stores 50 in old. So then the next line says pixel.setRead old times 2. So here I'm using an expression. And remember the way it works is when it gets to this line, the first thing it's going to want to do is evaluate the expression. So it's going to look at old times 2. Old, remember, is just storing 50. So basically this says 50 times 2. It's going to evaluate that, come up with 100. So it evaluates the expression to get 100. And now that it has that value, then it can go ahead and run the code. So it says pixel.setRead, essentially 100. So if you think through the whole sequence, basically this pulls the 50 out, multiplies by 2 to get 100, and then stores that back. So in effect, it multiplies by 2. Now, in reality, this is the way we're going to write it. The whole thing can be condensed down to just one line, because really that variable old there it wasn't adding a lot. It was just kind of a temporary holding spot. And so let's imagine that same case of a pixel where the red value is 50, and I'm just going to run this. I've just condensed it down to one line. So let's imagine this code running. So I have a pixel with, actually here I have it, a pixel with red of 50, and I'm going to run this line. So the first thing it's going to do is it's going to notice that there's an expression here, pixel.getRead times 2. So it's going to evaluate that expression. So pixel.getRead is going to go get what the red value is currently. So let's say 50. So it'll say it's the same math we had before. So 50 times 2, that's 100. And so then with that value 100, essentially it's going to call pixel.setRead of 100 to put that back. So it works out as the same dynamic we just went through. So it gets out the old value, multiplies by 2, and puts it back. Or in effect, sort of in English, it doubles the red value. So I'll do a bunch of examples that follow sort of this pattern. So what we're going to see is I'll start using this inside of loops, is whereas previously we had to, say 0 or 255, we would have some fixed number. But now we're going to write code, and this is the example I just did, code like this, where we're going to change the red value based on what the red value was before. And so the dynamic is we'll have, very often we'll say pixel.setRed, and then in the parentheses we'll call pixel.getRed, and then have some arithmetic. So in this case, this line doubles the red value, or alternately, this line calls pixel.setRed of pixel.getRed times 0.5. So it's getting the old value and multiplying times 0.5, or essentially dividing by 2, so it's going to make it smaller, and then put that back. So that's going to be the, we'll follow that pattern a lot of times. All right, so let me get to a real example here. So suppose I'm going to take the flowers image, and let's say I want to make it look kind of more orange. So my strategy is going to be, well, let's change the green value. Let's just turn down the green. And sort of mathematically, I'm going to say, let's change the green to be 75% of whatever it was. Now, in this example, I've actually started the page with no code in it. So I'm just going to actually type this in. So I'll say pixel. So if I want to change the green to be 75% of what it was, and this is similar to the examples I just showed, I'll say pixel.setGreen, and I'll sort of write this outside in. So I want to call setGreen, and then I want to put some kind of expression here, right? So compute a number that I want to put back for the green value. So the pattern I'm going to use here is I'll say pixel.getGreen. I'm going to get the old value, and then I could kind of multiply it times whatever. In this case, I'll multiply times 0.75. So I'll change it to be sort of 3/4 of whatever it was. So let's try that. Okay, so that does make it. If you recall, it was sort of yellow. Actually, if I put 1.0 here, we can make no change, right? So that was when it was nice and yellow. So I'll put 0.75 back here, and then we get it kind of a little more orange. I should say, for these examples, I'm gonna just take the time to type the code in, and you could do that if you want to go back on these yourself. There's a little show solution button down here. So if you come and review it later, the solution code is available, but I just felt like for practicing purposes, it's better to start with a blank screen and then really go through the process of typing the code in. So all these examples will follow that pattern. All right, let's try something a little more difficult. So this says, set red, green, and blue each to be 0.75 of their original values, and then try 0.5 and 0.25. So what I'm going to do, following a great computer science tradition, is instead of typing the code in absolutely from scratch, I'm going to copy it, the one I made before, and I'll just paste it. I'll make 3 copies of it, and then we'll fix it to do what I want here. Okay, so usually I always go in the order red, green, blue. So I'm going to say set red to get red, and what did it say? To 0.75. All right, so that one's good. And then we'll say set green to get green times 0.75, and then we'll do blue last. So set blue, pixel dot get blue. So you can sort of see the pattern here of the set and the get being combined. That's fine. It's a very workable pattern. So I'll run it that way. It's a little bit subtle, but what this has done is taken the original image and made it a little bit darker. Because if you think about it, by multiplying 0.75, we're sort of moving everything towards 0. And obviously 0, 0, 0 is pure black, so we're kind of compressing down that way. So let's try making it a little more extreme. So I'll multiply times 0.5, and I'll run that. Oh, it's a little darker. And if I'll multiply 0.25, so just a quarter of the original values. Oh, and then it's getting quite dark. So this shows a good, realistic, sort of interesting use of this kind of scaling idea of using set red combined with get red and multiplying times sort of number to sort of play with the values, either scaling them up or scaling them down. All right, so there's a third problem here. I'm going to sort of skip over. This one's just for extra practice if you want to come and try this one, and it has solution code as well. So what I really want to do is work one of these 5, 10, 20 puzzles. So the idea with the 5, 10, 20 puzzles is that there was some image of a flower or a piece of fruit or something, and it's been modified. And the way it's been modified is that the red, green, and blue values have all been divided by either 5, 10, or 20. So the values are way too small. The image is going to be really dark. And the challenge is to multiply the red, green, and blue values by either 5, 10, or 20, essentially to kind of undo the darkening, to kind of get the image back. And so essentially this just comes down to sort of experimenting and playing around a little bit to try and figure out how to get the image back. So the number 5 is used once, the number 10 is used once, the number 20 is used once. So basically you just have to figure out which one goes with which color. And I should say, there's only 6 possible ways to have 5, 10, and 20. So there's not really that many to go through. The way I think about it is you could imagine, well, maybe the 5 is first, is on red. And so then there's either, if 5 is first, then there's either 5, 10, 20, or 5, 20, 10. So if 5 is first, there's only 2 possibilities. And then likewise, if 10 is first, there's only 2 possibilities. And if 20 is first, there's only 2 possibilities. So that's the way you can kind of organize the way you're searching through this. All right, so let me go back here, as I said before, and grab a copy of my code so we won't start with nothing. All right, so in this case, what we have is a banana. Actually, here, I'll comment these lines out for a second so we can just see what the image looks like with nothing. So there is the puzzle image, and what it showed, I'll tell you, there's a yellow banana, and it's on a background of dark red bricks, and in between the red bricks there's little bits of green moss you can see. So if you fix the image, we should be able to see all of those things. So to fix the image, what I want to do here is multiply. I'll just start with 5, 10, 20 like this. So I'll say, well, let's guess that the red needs to be multiplied by 5, the green needs to be multiplied by 10, and the blue has to be multiplied by 20. It's just a guess. So if I do that, that's clearly wrong, right? The banana doesn't look quite right, and the bricks have this sort of blue cast, so that's not good. So I'll stick with the assumption that the 5 is first, though, and I'll try the other permutation. All right, well, so maybe it's 5, 20, 10. So I'll try it that way. Ooh, that's worse. All right. So I don't think the 5 is first, right? I tried the 2 ways with 5 first. So let's try the 10 first. So I'll try 10, 5, 20. All right, so I'm just scaling these up. Ooh, Well, I mean, I think we're getting there, right? I mean, the banana looks pretty good, but the bricks obviously are, that's purple. They're supposed to be red. So let me try, I'm going to try leaving the 5 in the middle and just putting the 20 first. 25, 10. Let's try that. Ah, there we have it. There's the banana. Looks nice and yellow. You can see the bricks have this dark red color, and then even little bits of green moss here. That's sort of reassuring. So I'm going to zoom in on this. I'll show you some slightly subtle qualities of it. So partly there's the brick and the moss and the banana. That all looks good. This is just a minor thing, but you'll see there's there's sort of this horizontal banding in the banana, and that's okay. That's the way the solution looks when you do it correctly. That's happening because when the red and green and blue, when they were divided by these numbers, by 10 or maybe 20, all of those values, which normally range from 0 to 255, they were compressed down to ranging maybe just 0 to 12 or 0 to 24. And as a result, because they were compressed down to that range, there were just a few shades of yellow available when it was compressed down like that. And even when we expand it back up, we're still stuck with just those few shades. So that's what we're seeing in these horizontal bands here. There were just a few different shades of yellow, and so it's unable to capture. I'll zoom in a little bit. It's unable to capture the real gradations that you would want. And so that's just sort of an artifact of the way this exercise worked. All right. So the exercises to follow this section are actually just more of these 5, 10, 20 puzzles. So something you should check out.